on the most basic level, what are you developing at BillionToOne? What is the scope and significance, and what was the status quo before your technology?
Molecular diagnostics is really changing. And one of the things that scientists have realized in the last decade that all of our tissues are shedding fragmented cell-free DNA into the bloodstream. So these are kind of little pieces of DNA that are coming from all of your tissues, all of your cells. And it is essentially a microcosm of your body in a blood sample, right? If you can take that blood sample, you can potentially see what is happening in a tumor for cancer testing, in a developing baby. You don't have to do these invasive methods of really trying to get a tissue sample directly from that cancer or from that fetus. Those can be invasive, difficult. They can lead to miscarriage. What we have done at BillionToOne is that we have developed quantitative ways of looking at cell-free DNA. And in particular, we have developed a way to count DNA molecules, which in turn improves the resolution of this diagnostics by more than 1,000-fold. So previously, people could only look at kind of really large-scale changes, which means that they can't look at most of the genetic changes that are happening. They would miss mutations for cancer care. They would only be able to look at a handful of disorders that are at the chromosome level. So we improve that resolution by orders of magnitude so that we can even see a single base pair change. So if you think of your genome as a huge library, right, previous methods could only say that this whole section is missing, whereas most disorders are caused by kind of one letter change in one of the books in that library. So we have developed the only method to be able to find that one change.